Hi students, in this video I'll be going through the 2023 O-Level A Math Paper 1 question 7. Right, so this is a question related to the discriminant and the nature of roots. Okay, so let's read the question. Find the set of the values of the constant k for which the curve y equals to kx squared plus 4x plus k minus 3 lies completely below the x-axis. Alright, so this curve, this over here, this y equals to kx squared plus 4x plus k minus 3 is a quadratic curve, right? So it's either a smiley face or a sad face. Okay, but from the next statement right over here, okay, lies completely below the x-axis. So we know that it has got to be a sad face already, because if it's a smiley face, it can't be lying completely below the x-axis. Right, so let's draw and see for ourselves how it would roughly look like. Okay, so you're going to draw your axis. Okay, so if it lies completely below the x-axis, then it may be something like this. All right. Okay, so this is the curve. Kx squared plus 4x plus k minus 3. Okay, right. So it lies completely below the x-axis. Right, so over here, if it lies completely below the x-axis, then it does not intersect the x-axis. Right, so basically what we are going to try to do is we try to solve, okay, to find the intersection points between this curve and the x-axis, and then we should not be able to find any intersection points. In other words, there will be no real roots or no real solution when we try to solve this equation 1 over here. And then this equation, okay, so the x-axis also has an equation, which is y equals to 0. Because if you recall on the x-axis, right, the y coordinate of every point is 0. So actually the x-axis, the equation is y equals to 0. So let's call this equation 2, okay, over here. So when we try to solve simultaneously equation 1 and equation 2, we should not be able to we should not be able to find any solutions. In other words, the equation will have no real roots, right? Okay, so let's go ahead and try to solve. So, so we'll write this, kx squared plus 4x plus k minus 3. Okay, so let's call this equation 1. And then the x-axis, the equation y equals to 0. Let's call it equation 2. Okay, so when we equate 1 and 2, okay, then we will get this equation, right? Equals to 0. Okay, so when we try to solve this equation, we should not be able to get any real roots. Okay, so let's write this statement. So if y equals to kx squared plus 4x plus k minus 3 lies completely below the x-axis, okay, then okay, the above equation kx squared plus 4x plus k minus 3 equals to 0 has no real roots. Okay, then this brings us to the next idea, okay, of the discriminant. So if a quadratic equation has no real roots, what can we say about the discriminant? Okay, so you should recall that the discriminant would be less than 0. Okay, because the discriminant, if you recall in the quadratic formula, discriminant is the term, right, okay, that is inside the square root. Okay, so this is the discriminant, b squared minus 4ac over 2a. Okay, so this is the discriminant. Okay, so if the discriminant is less than 0, you can't square root a number that's less than 0 to get a real number, and hence this whole thing will have no real roots. Okay, no real solutions for x. So we can go ahead and write, so b squared minus 4ac will be less than 0. Okay, so we will extract the a, b, and c from the equation. So b will be 4. Okay, so 4 squared minus 4. A would be a k in this case. Okay, then c would be the k minus 3. Okay, so in other words, now we are just left with the simple task of solving this inequality. So 16 minus 4k times k minus 4k squared. Okay, negative 4k. Okay, so this whole thing is together. Negative 4k times negative 3, so you get plus 12k less than 0. Okay, so let's rearrange this one first. So if I rearrange this, I get a quadratic inequality in terms of k. Okay, so usually we are more familiar with dealing with positive coefficient for k squared. So what we can do over here is we can divide by negative 4. Okay, but when you divide by negative 4, negative number for an inequality, you need to be careful to reverse the direction of the sign. So minus 3k minus 4 will be now greater than 0. So do be careful about this. Reverse the direction of the sign. Okay, so now that the numbers are smaller, okay, we can then factorize this, and then we can solve the inequality. Okay, so over here you should be able to get a k plus 1 and then k minus 4. So go and check, expand back and check if you are correct or not. Okay, so this is correct, right? So remember, to solve a quadratic inequality, you need to always do a rough sketch. So in this case, the roots will be at minus 1 and at 4. Okay, and this will be a smiley face because the coefficient of k squared is now positive. Okay, what you want is a greater than 0, so you want these parts of the solution. Okay, the parts where the curve is above the x-axis in this case, so called the k-axis. Okay, actually this should be the k-axis. Okay, so we want this part. So in other words, the solution would be k less than negative 1 or k greater than 4. Okay, so whenever you obtain any solution, you need to then check whether both sets are valid. All right. So k less than negative 1, is it okay? Okay, remember k is the coefficient of x squared of the original quadratic equation. So since it's always is a set face curve, right? So k has got to be a negative number. Okay, so k less than negative 1 is all right. Okay, but k greater than 4 will not be okay, because if k is greater than 4, then this curve is going to be a smiley face. It's impossible for a smiley face curve to be always less than 0, because you cannot draw a smiley face curve like this. Okay, because the curve will continue upwards and then eventually it will cut the x-axis and become greater than 0. Okay, so in other words, you've got to reject k greater than 4. Okay, anyway, now I'll bring you to Desmos. So I've drawn two graphs using Desmos. One for the value of k less than negative 1. So actually what I used was I used k equals to negative 2 lah. Okay, then for this one, I use k equals to 5. And then you can see that for k equals to 5, right, the curve will not be able to be always less than 0 or completely below the x-axis. All right. Okay, so let's go over to Desmos. So over here, I've used k to be negative 2. Okay, so I got this red color graph, and you can indeed see that it's completely below the x-axis. Right, so the x-axis is over here. Right, so then after that, I use k equals to 5, and you can see that the curve is now completely above the x-axis instead. Okay, so there are no values of so you cannot accept the second answer where k is greater than 4, because it will make the original question not valid, right? Okay, so I hope that this going through this solution has helped you to understand such questions better. So it's a 6-mark question, but as you can see, it's actually not that difficult.